Friends, the next question is pH of aqueous solution of 0.1 molar ammonium formate assuming complete dissociation. pKa of formic acid is equal to 3.8 and pKb of ammonia is equal to 4.8. Now, they have given us ammonium formate HCOONH4. Ammonium formate on hydrolysis gives formic acid plus ammonium hydroxide. Formic acid is a weak acid, carboxylic acids are all weak, ammonium hydroxide is a weak base. So ammonium formate is a salt of weak acid and a weak base. For a salt of weak acid and a weak base, pH can be calculated as pH is equal to half of pKw plus pKa minus pKb, where pKa is dissociation constant for an acid, that is minus log of dissociation constant of an acid. Kb is the dissociation constant for a base, whereas pKb is minus log of Kb. Half of pKw, where Kw is ionic product of water and pKw is minus log of Kw, and at 25 degrees Celsius the value of pKw is 14 plus pKa for formic acid is given 3.8, pKb 4.8. If you subtract it, the value will be equal to 13. So half of 13, that will be equal to 6.5. Hence option A, 6.5 is the right answer. The next question is, for two acids A and B, pKa of one acid is 1.2, pKa of another acid is 2.8 respectively. That is, pKa for acid A is 1.2 and pKa of acid B is 2.8. Then which is true? Option A and B both are equally acidic. Option B, A is stronger than B. Option B, B is stronger than A. Option D, none of this. Let us try to find the relation between Ka and pKa, and we'll try to relate them with the strength of an acid. Ka is dissociation constant. Larger the value of Ka, stronger will be the acid. Let us consider an acid whose Ka value is 10 raised to minus 3. Let us consider another acid whose Ka value is 10 to the power minus 2. So if we go according to the Ka, so Ka with 10 to the power minus 2 is a strong acid. Why? Because the value of Ka is large. Larger the value of Ka, stronger will be the acid, and Ka gives you information regarding the strength of an acid. If we calculate the pKa for this, pKa is given by the formula minus log of Ka, that is equal to minus log of 10 to the power minus 3, that is minus of minus 3 log 10 is 1, you get plus 3. If we calculate the pK for second acid, that will be equal to minus log of K, that is equal to minus log of 10 to the power minus 2, that is log of A raised to x is x log A minus of minus 2 log 10, that will be equal to 2. That means from this we can come to a conclusion that larger the value of Ka, stronger will the acid, and the one which is stronger acid will have lower pKa value. So lower the pKa value, that will be the stronger acid. If you look at the question that is given, they have given you two acids A and B. Out of that, one acid has pKa 1.2, other acid has pKa 2.8. The acid with pKa value 1.2 is stronger. That means acid A is stronger than B. So hence option B is the right answer. That is, A is stronger than B. Student, the next question is, which of the following will not undergo hydrolysis in water? Option A, sodium phosphate. Option B, sodium acetate. Option C, sodium nitrate. And option D, both of A and B. Hydrolysis. Salts, when they dissolved in water, they undergo hydrolysis. Generally, the salts made up of, that is formed by the combination of strong acid and strong bases, do not undergo hydrolysis, because after they react with water, they again give strong acid and strong base, which mainly remains in its dissociated form. So salts of strong acid and strong base does not undergo hydrolysis, whereas salts of weak acid strong bases or strong acids weak bases, these generally undergo hydrolysis, because on treating with water they form corresponding weak acid or a weak base. So which of the following does not undergo hydrolysis means we should find the salt which is made up of strong acid and a strong base. If a salt is made by a combination of strong acid and a strong base, that does not generally undergo hydrolysis. Let's try, we just analyze the question one by one. Option A, sodium phosphate. Sodium phosphate, when treated with water, it gives sodium hydroxide, that is Na plus, reacts with OH minus, whereas phosphate reacts with H plus to form H3PO4, where NaOH is a strong base, H3PO4 is a weak acid. Now, sodium acetate, CH3COONA, when treated with water, it gives acetic acid plus NaOH, where acetic acid is a weak acid and NaOH is a strong base. So sodium phosphate on hydrolysis gives you weak acid, sodium acetate on hydrolysis gives you weak acid. So hence these undergo hydrolysis. NaNO3. NaNO3, when treated with water, when you treat NaNO3 with water, it forms. Na reacts with OH minus to form NaOH, H plus reacts with NO3 minus to form HNO3. So NaOH is also a strong base, HNO3 is a strong acid. So this salt is formed by the combination of strong acid and a strong base. So on adding water, it forms corresponding strong base and strong acid. Strong base, they remain completely in their dissociated form, that in the solution they form Na plus and OH minus ion, where HNO3 also forms H plus and NO3 minus ion, that is it undergoes complete dissociation. So hence they do not undergo hydrolysis. Hence option C, that is sodium nitrate, is the right answer.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.